Today we're going to use all of our factoring methods to solve word problems, and this is the application of factoring. So a quick overview as far as solving quadratic equations in general. The first thing is that we've actually already covered one of the forms of factoring, solving equations, and that is using factoring, and that is in Chapter 8. The remaining three methods, there are 4 total methods, the remaining 3 will be covered in Chapter 9 when we cover Chapter 9, and that would be graphing, so there is more graphing coming up, completing the square, which is another method, and finally quadratic formula, which is a method we will derive. So let's go ahead and get started. We're going to start by reviewing some of our problem-solving methods here, So as we start problem solving once again, just a quick review of our 4 steps to problem solving. Step 1, first thing is we must define the variable or variables, draw a diagram as we need to. Some cases we may need a chart or a table, other cases we need to draw the picture so we can see what's going on. Second step is to write the equation or equations in some cases, as in the case of systems of equations, when we have 2 or more variables with 2 or more equations. Third is to solve the equation or equations and identify the solution or solutions. And finally, step 4 is to check, make sure that we followed through correctly, and also answer the question in a complete sentence. This is to make sure that we've answered what they've asked for in the problem. So we're going to go ahead and move on to our first example right now. Example number 1. Find 2 consecutive positive odd integers whose product is 143. Now I'm going to do a quick side note of review. Consecutive integers, just a quick review here on the side. Recall that there were 2 kinds of consecutive integer problems before when we did consecutive integers. So quick review. Consecutive, meaning one following after another, integers. And there were 2 cases back when we did this in Chapter 2. First case was what we called the non-skipping type. Non-skipping was when we had just consecutive, straight consecutive, meaning example 1, 2, 3, consecutive numbers. So what did we do back then? We said let n equal our first integer. Then following from the first one to get to the second one, we needed to add 1. So we did n plus 1 is our second integer. And then from our first one to get to our third one, we had to add 2. So we did n plus 2 to get our third integer. This is what we called non-skipping, because they didn't skip at all. We went 1, 2, 3, directly 1 to 2, then to 3. Then we had our skipping type. Skipping was what we called the odds or evens, because they skip to get to the next number. For example, let's say odds 1, 3, 5. For me to get to 1 to 3, I have to skip over a number. So let's say if I had let n equal my first odd integer, what would I need to do to get from 1 to jump to 3? I have to skip over a number, so I would have to add 2. So n plus 2 would give me, 1 plus 2 would give me 3. So n plus 2 would give me my second odd integer. Then from 1 to jump to 5, I would have to add on 4. So this would be my third odd integer. And it so happens that this works as well for the evens. So let's say 2, 4, 6 is our even numbers. So if I said let n equal my first even integer, what would I have to do to 2 to get to 4? I would have to add on 2. So n plus 2 would be my second even integer. And then from 2 to 6, I have to add on 4, which is my third even integer. Now if you take a look, you'll notice that the definition of variables for odds and for evens are identical. n plus 2, n plus 4, n plus 2, n plus 4, because we do have to skip this in the same way. So quick side note, make sure to jot this down if you need it for review, because we will encounter these type of problems once again in this section today. Okay, so going back to our example again, okay, now that we have that side note. Example number 1, find 2 consecutive positive odd integers whose product is 143. So in this case, I need 2 consecutive odds. They happen to be positive. So since we need 2 of them, we're going to define 2. So let n equal my first positive odd integer. Okay? And then I need the next one. So this one is a skipping case. So the next one would be n plus 2 is my second positive odd integer. And then it says whose product. Recall what product means? Product is when you multiply. It's an answer for multiplication. So step 1, we did our defining our variables. Okay. Now moving on to step 2, I'm going to write my equations. So I need product. I need these 2 to give me a product, so I'm going to multiply n times the quantity n plus 2, and it is or equals 143. So now that I have my equation, step 3, we're going to go ahead and solve this equation. Okay? So solving, I need to make sure, as our previous lesson indicated, if I have this type of problem, I need to make sure to simplify this piece first. So simplify meaning distribute this, so I get n squared plus 2n equals 143. And remember, in order to solve a quadratic, we have to make it equal 0. So I'm going to go ahead and make this equal 0, subtract off my 143, both sides. So I have n squared plus 2n minus 143 equals 0. Notice I did not combine these are not like terms. And it is in descending order, because I know the next step will be to factor. So now I need to factor out this trinomial here. First step is GCF. Is there a GCF? Nope, there doesn't happen to be anything in common here. Step 2, once I try GCF, let me see if there's a perfect square trinomial here. Is this a square? Yes. But 143 is not a square, nor is a negative. Since this is a negative, I know right away it cannot be a perfect square. So then I'm left with x box. So I'm going to go ahead and factor that in my x box right now. This is my product, negative 143, since this is a coefficient of 1. And my sum happens to be a 2. And this is an indicator. The problem says odds, so I know I'm looking for odd numbers. So I know that 1 happens to be a common factor for everyone, but 1 times 143 will not give me a sum of 2. So I'm going to try 3. 3 doesn't work because 1 plus 4 plus 3 is 8. This is the divisibility rule for 3. The sum of the digits is not divisible by 3, so 3 does not work in this. 5 doesn't go into this because it doesn't end in a 5 or a 0. So then I'm left with 7, 11, then 13. So let me try 7. 7 does go into 14, but if it goes into 14, it doesn't go into 3, so 7 won't work for this. Let's try 11. I'm just going to try this on the side. 11 into 143 goes in once. That gives me 11. 33. Nice. So 11 times 13 happens to be my 2 factors for this. So 11 times 13, then, and it does happen to add up to 2 if, which one is negative? Negative on the 11, because this product is a negative, so it has to be a negative times a positive, and the sum happens to be a positive 2. So my 2 factors are negative 11 and 13. So now I'm going to go ahead and replace it. So this is n squared minus 11n plus 13n minus 143 equals 0. Now the box part of my x box, I'm going to go ahead and fill in my box. And this is plus 13n and minus 143. Factor my common factors here. My GCF is n on this top level. The bottom, I know that 143 is 11 times 13, so 13 will go into that, positive 13. Then go vertically, n times n gives me n squared, so that works. N times negative 11 will give me negative 11n. Now verify. 13 times n is 13n. 13 times negative 11 is negative 143. So my 2 factors here are n plus 13 times n minus 11 equals 0. Then I'm going to continue solving, okay? Solving the factors, so I need to make sure each factor equals 0. N plus 13 equals 0, then n minus 11 equals 0. n plus 13 equals 0, subtract 13 on both sides, so n equals negative 13. Add 11 on each one for this one, and n equals 11. Okay, so my solution set would be negative 13 and 11. However, I need to make sure I answer the question. So going back to the question itself, it says find two consecutive positive odd integers whose product is 143. Now going back, my solutions are negative 13 and positive 11. I need the positive case. So if I take the positive case, that would mean my solution here would be n equals 11. Okay, so if n is 11, let me go back to the beginning of my problem once again. N is 11. We found that this is 11. If n is 11, then n plus 2, that would be 11 plus 2 would give me 13. So my two integers would be 11 times 13 would have to give me 143, and that works. So the answer to this one, the positive odd integers are 11 and 13. Okay, and that's step 4. We just checked it, and then we wrote our complete sentence. Now, the negative 13 answer that I have at the bottom here will not work because it didn't ask for negatives. So I'm going to throw that out and throw out that answer. Okay, so this would be my answer. The positive odd integers, or positive consecutive positive odd integers, are 11 and 13. Okay, so I have one for you to try at this time. On your worksheet, go ahead and try problem number 5. Okay, moving on to our next example now, example number 2. Okay, number 2 says, find the dimensions of a rectangle whose perimeter is 102 feet and whose area is 144 square feet. So we're going to go ahead and draw a diagram for this one as we get ready to solve this. Okay, dimensions, another review word here. Dimensions means I'm looking for length, width, height. Okay, so if I have a rectangle, the dimensions happen to be length and width. So I'm going to go ahead and draw my rectangle. Okay, I need a rectangle whose perimeter is 102 feet and whose area is 144 feet squared, or square feet. Okay, and I know I'm going to have a length and a width for my rectangle. Okay, so let me go ahead and define that right now. Let L equal the length of my rectangle, and let W equal the width of my rectangle. Okay, I can also define at this time what my perimeter and my area are based on the formulas that I know. Perimeter, the formula for perimeter on a rectangle is 2 widths plus 2 lengths, also known as 2L plus 2W. And that's perimeter, and this perimeter happens to be 102 feet. Okay? I also know the area of a rectangle is length times width, so my length times my width is 144 feet squared. So I'm going to go ahead and fill that information in as well right now. So what I have in front of me basically is 2 equations already written. I filled in my perimeter formula and my area formula. This is my perimeter, and this is my area for my rectangle. Now we're going to go ahead and solve. Now if you take a look, I have 2 variables with 2 equations. So this is a systems of equation. So basically what I'm going to do is solve one and replace it in the other, otherwise known as substitution. Okay? So I'm going to go ahead and use my perimeter form here. Okay? And let me go ahead and solve for one of the variables. I'll go ahead and solve for L in this case. Okay? So I'm going to bring this down here. If I have 2L plus 2W is 102 feet, then what I could do, I noticed that I can factor out a 2 here. So 2 times length plus width is 102 feet. Couldn't I divide by 2 here? And I get length plus width must be 51 feet. Okay? Now what I can do is, once I have a simple equation like this, I'm going to solve for one in terms of the other. I'm going to go ahead and solve for L. So L equals 51 minus W. You could have also solved for W. It depends on whichever one you'd like to solve for. Now I'm going to take this and replace it into my other equation. My other equation was length times width is 144 feet squared. So I'm going to go ahead and solve now, replacing my L with 51 times W. So minus W. And then multiply it by the W, which is this, equals 144. Okay? Now, from the previous problem, we know that in order to solve this, we need to go ahead and simplify this first. Okay? So 51W minus W squared equals 144. I'm going to go ahead and make this equal to 0. So, and I do want to write this in descending order, preparing to factor again. Okay? So negative W squared plus 51W minus 144 equals 0. I want descending order so I can factor this. Okay? Now, I notice that I have a leading coefficient of negative 1. I'm going to go ahead and factor out a negative 1 right now as my GCF. So this is W squared minus 51W plus 144. That makes this a little easier to factor. I see that I have a trinomial. The first is a square, the last is a square. I can check to see if this is indeed a PST. So I would have W squared, this would be 12 squared. Now let me check the middle. 12W, I need a double, and this doesn't work. So this is not a PST. So since it's not PST, I'm going to go ahead and finish solving using Xbox for factoring. Okay? So finishing up my factoring here, I'm going to go to Xbox. So I have a product of 144, and my sum is negative 51. Since my sum is negative, I most likely will have two negatives, because two negatives multiplied together will give me that positive, and added together will give me a negative. Okay? So 144, and I don't know any off the top of my head right now, so I'm going to go ahead and check. 1 times 144, 2 times 72. Notice I'm just going in order just to make sure I don't miss any of them. Okay? 3 times, 3 goes into here 48 times. 4 goes in here, it looks like 36 times. 5 doesn't work. 6 times, 6 would go in here 18 times. Is that correct? Or no, it doesn't go in 18 times, I'm sorry. 6 times, 6 would go in there 24 times, right? Goes into 24, yeah. And then I'm going to try 8. 8 would work. 8 is the 18 times, okay? And then I have 9 and 16, and then 12 and 12. So out of these, I need to find a combination that will give me 51. So these are all my possibilities right now, and the closest one I see is this one. 3 times 48 would give me 51. So negative 3 and a negative 48. Okay? So now I'm going to go ahead and finish my factoring by replacing. So I've got a negative 1, W squared minus 51W plus 144 equals 0. That's where I left off. Okay, so I'm going to go ahead and keep solving here. So if I replace, I get W squared minus 3W minus 48W plus 144. I'm going to go ahead and box this now. So this is a W squared minus 3W minus 48W and a 144. So this is W, and this happens, 48 does go in 3 times, so I'm going to take out a 48 negative there. And then vertically, W times W is W squared. This is negative 3. And that checks. Negative 48 times W, negative 48W, and that checks. Negative times negative will give me a positive 144. That checks. So this is what I now have. My GCF was negative 1, and I had a W minus 48 times a W minus 3 equals 0. Okay? So now I'm going to continue solving, making each factor equal to 0. Negative 1 equals 0. W minus 48 equals 0. And finally, W minus 3 equals 0. Okay? so each set equal to 0. Okay, this one doesn't work. -1 does not equal 0. We can toss that one out right away. We're going to solve for this one, 48. So I get W equals 48. Add 3 on this one, so I get W equals 3. So right now I have a solution set of W could equal 48 or positive 3. So I'm going to go back to my original problem now. Okay, original problem was length and width, right? I need something whose length and whose width will give me a perimeter of 102, yet an area of 144. So I'm going to try that. I'm going to go ahead and replace it. Okay, if W is my width, okay, if W is my width and it is 3 feet, then that would mean my length must be 48 feet, because 48 times 3 does give me 144, and perimeter 2 times 48 gives me 96, 2 times 3 gives me 6, it does add up to 102. So perimeter works and area works. So the width or length, or we could just say dimensions, since the problem did say dimensions, we could say the dimensions of the rectangle are 3 feet by 48 feet. And that would be the end of that problem. Okay? Okay, so now it's your turn. We're going to go ahead and give you a problem to try. On your worksheet, go ahead and try problem number 12 on your own. Go ahead and pause and give that one a try. Okay, moving on to example number 3. Okay, example number 3 is a lengthier problem. Go ahead and take a moment to read that. Okay, we're going to go ahead and draw a diagram for this one. Okay, originally a rectangle was 8 centimeters by 17 centimeters. Okay, so I'm going to start diagramming this right now as I read this. So originally, my original rectangle was 8 centimeters by 17 centimeters. Okay, I'll call this my original right here. Okay, when both dimensions were decreased, so in other words, I'm going to make it smaller. I'm going to use a different color here. I'm going to cut off a piece here, and then I'm going to cut off a piece here, and I'm going to make a smaller rectangle in here. Okay, so when both dimensions were decreased by the same amount, we don't know that amount, there's some amount here that was decreased in here, the area of the rectangle decreased by 66 centimeters squared. In other words, the part that I cut off, this part here, the cut off part was 66 centimeters squared. Okay? Now I need to find the dimensions of the new rectangle, so the smaller one that's in here. Okay? So now that I kind of have an idea of what's going on in the problem, let's go ahead and set this up. Now, the one thing I don't know in this problem is the amount that was decreased. So let me go ahead and set a variable for that. So let x equal amount side is decreased. Okay, so let's say this is an x and that's an x. That's how much we're going to decrease it by. Okay, and if I decrease it, then my new rectangle, this portion in here, will have what length here if I decrease it. So if you take a look, it's originally 17, but I'm going to chop off this x, which means it's now missing an x. So this must be 17, take away the x. And I can do the same thing going the other direction for its width. It was 8 centimeters, now I'm chopping off an x. So this is now 8 minus x. So my new dimensions for my new rectangle, okay, so my new rectangle will have the dimensions of 8 minus x. and 17 minus x. And that's my new rectangle. Okay. Now, there are many ways we could do this problem. Okay. We could add on, or we could do what we did in the previous chapter, like a donut problem. We could take the whole entire rectangle, then chop off the missing part, and we know this is the leftover. We could do it that way as well. There are many ways to do this one. Okay. So why don't we do that? Why don't we do this just like our donut problem, okay? For our donut problem, we need the whole entire rectangle minus, okay, the portion they took out, and they decreased it by that 66, okay? And that would be the chopped off part. We'll just call it the chopped off part, okay, which happens to be the 66 centimeters squared. And if I chop that part off, I'll get my new rectangle. Okay, so the whole entire would be my old rectangle. Let's put it that way. Okay? Okay, so let's go ahead and get to work. Let's figure this out now that we have an idea of what to do. So my old rectangle, the original one, as stated in the problem, was 8 centimeters by 17 centimeters. Okay? So my original rectangle area would be 8 times 17, minus the chopped off part, which is 66 centimeters squared. And it would equal my new rectangle. And we just figured out our new rectangle would have a length of 17 minus x and a width of 8 minus x. Okay? So now that we have an equation, that's part 2, let's go ahead and get working and solve this equation. Okay? So first I have to figure out what's 17 times 8. So I get 6, that's 56, 136, minus the 66, must equal this, which I do need a FOIL out, okay? And I just did 17 times 8, which happens to be 136. I'm going to go ahead and FOIL, so minus 17x minus 8x plus x squared, okay? That doesn't mean it's time to go yet. We need to finish this problem. Okay, so let's go ahead and finish that problem. This gives me 70 if I find the difference here. And I get 136 minus 17x minus 8x plus x squared. And I notice I can go ahead and simplify here. 136 minus 25x plus x squared. Now, how are we going to solve this problem? This goes back to our previous lesson again. In order to solve a quadratic, that means anything that's ax squared plus bx plus c form, I need to make it equal to 0. So I'm going to go ahead and subtract off the 70 on both sides right now. And I'll get 0 equals, this gives me 66 minus 25x plus x squared. Now, in order to solve this, remember, I want to go ahead and put this in descending order. That way I can factor it more easily, okay? So let's go ahead and do that. Let me go ahead and rewrite that in a descending order. So that'll be x squared minus 25x plus 66 equals 0. So we're going to continue solving, okay? Is there a GCF? Nope, no GCF. So let's go ahead and go to the next step, which is PST, since there are 3 terms. First is a square, but 66 is not. So I cannot do a PST on this. So finally, let's go ahead and go to the X box. You'll notice X box is what we fall to automatically if nothing else works. So I have 66, and I have a product of negative 25. So seeing that my product is positive and my sum is negative, I know I'm going to have 2 negatives here. Only a negative times a negative will give me a positive, yet added together will still give me a negative. Okay, so let's go ahead and start brainstorming. What's 66? Well, I've got 1 times 66. That will not work. I've got 2 times 33. That will not work. What about a 3 times a 22? Hey, isn't that 25? Because my last one, of course, would be 6 times 11, which doesn't work either. So 3 times 22. 3 and 22 happen to be the factors in that one. Let's go ahead and replace that now. So I get x squared minus 3x minus 22x plus a 66 equals 0. Now the box of my x box. So I get an x squared minus 3x minus 22x plus 66. And I'm going to go ahead and start factoring. I've got an x as my GCF here, and a negative 22. Now vertically, x times x is x squared. X times a negative 3 would be a negative 3x. And this works, negative 22x. Negative 22 times a negative 3 gives me a positive 66. So my factors are x minus 22 times x minus 3 equals 0. Now, continue solving. Factor x minus 22 equals 0, and the other factor, x minus 3 equals 0. So, as I continue solving and talking at the same time, I get x equals 22 in this case. Adding 3 on this one, I get x equals 3 in this case. So my solutions here are 22 and 3. Yet, I'm not done with the problem yet, because now I need to go back and check and see what works. Okay? Now, if I solve and find out my two possible answers are 22 and 3, let's see if it'll work, okay? So, if I put it back in my picture and take a look, if I put 22 as the part that I chopped off, is that even possible? Because originally my length is only 17. Can I chop off more than what I already have? So, if I took off 22, I'd have a side of like negative 5. Does that work? And on this side, I'd have 8 chopping off 22. I would have a side of negative 14. Would that work? So checking 22 doesn't work for my new rectangle. So I'm going to throw out 22. Okay, and this is why it's important we check, because you may find out one of your answers or both of them might not work. If both of them don't work, you would write no solution. But in this case, let's see, 22 doesn't work. What about 3? If I try 3, 3 in here would give me a new length here of 14. So 14 would be my new length this way. And if I had this side as a chopped off a 3, I would have a new length of 5 this way. So I get 5 times 14, which would give me a 70 for the area of my new rectangle. And I chopped off 66. So would the 70 plus the 66 give me 136, which was 8 times 17? And it does. So it checks. So my new rectangle must have lengths of 14 by 5 centimeters. Okay? So I'm going to go ahead and now answer the question. The question said, find the dimensions of the new rectangle. So what are the dimensions of my new rectangle? 14 centimeters by 5 centimeters, which I did plug into this, or also noted right here. Okay, so I'm going to answer this. Okay, the dimensions of the new rectangle are 14 centimeters by 5 centimeters. Done. Now it's your turn. Go ahead and try problem number 14. Okay, bring that to class with the other two problems, and we'll see you tomorrow.